Recently, a wave of ambitious robotics companies has emerged, sparking intense interest worldwide. Like 1X Neo have marketed their bots as the ultimate home assistants, and Unitree Robotics has got the Unitree G1, boasting impressive specs. Meanwhile, Boston Dynamics' iconic Atlas has captured public fascination for years. However, these breakthroughs remain largely in promo videos. No one's actually seen these robots doing real-world things. In contrast, Tesla is an amateur whose main expertise is EV manufacturing, developed the humanoid robot Optimus in less than 3 years. More importantly, Tesla's gone beyond the lab. Optimus units are actively working in Tesla factories, and the company even aims to offer individual customers the opportunity to try them. This level of real-world deployment sets Tesla apart. So, how is the Tesla Optimus really different? But before we dive into the exciting new design and impressive upgrades of Tesla Optimus in today's episode, make sure you hit that subscribe button and turn on those notification bells so you never miss out on any Optimus updates. How does Optimus achieve up to 95% accuracy in its activities? Optimus isn't your typical robot. It's built with human-like dexterity in mind. This machine's equipped with arms that are roughly 5 feet long and hands with 5 articulated fingers, boasting a remarkable 22 degrees of freedom. And here's the kicker. Its fingers are fitted with high-precision sensors that allow Optimus to perform tasks that require accuracy and finesse, like cooking a meal or putting together furniture. These hands don't just open and close, they move with finely controlled accuracy thanks to micro-actuators, imitating human precision in a way few robots can. When you compare Optimus to other so-called advanced humanoid robots, it stands out. Take Boston Dynamics' Atlas, for instance. While Atlas is incredibly skilled at agile movements, its two-fingered clawed-like hands are kind of limited, lacking dexterity needed for complex tasks. Watching Atlas can almost feel like watching an industrial machine running in a factory. It's functional, but not exactly what you'd imagine when picturing a robot designed to interact in human environments. Then there's Figure 2, a newer robot on the scene, with an even closer approximation of human anatomy. It looks sleeker than Atlas and sports a 5-fingered hand, but despite going through 4 generations of upgrades, Figure 2's hands only have 16 degrees of freedom. The functionality is limited, it can grip and release, but that's about it. In recent video updates, we've seen Optimus's joint mechanics in action, allowing it to bend at a full 90 degrees, moving in ways that are strikingly human-like. This design lets Optimus handle tasks with natural freedom of movement, crucial for complex assembly and manipulation. Since its debut, however, we've mainly seen Optimus tackling basic tasks like doing laundry, holding an egg, and sorting batteries on an assembly line. Frankly, it's kind of underwhelming compared to what most of us were hoping for. People want to see more. They want to see practical utility in the real world, not just staged demos and Tesla video updates. Imagine the possibilities. Optimus carrying trays of battery packs in a factory, helping load groceries from a car into your house, even completing more intricate tasks like making and serving coffee to guests. Each of these demands an advanced degree of dexterity and coordination that isn't exactly simple to achieve, especially for a robot. And if you're curious about the full range of tasks that Optimus can handle, dive deeper into our latest video, New Tesla Bot Optimus Gen 3 Capabilities Shock Industry. Elon reveals massive reservation on December for all the exciting details. When it comes to performance, Optimus's vision system is reported to have an object recognition accuracy rate of over 95%, allowing it to correctly identify and differentiate between a wide range of items. So if it's helping you assemble a piece of furniture, rest assured it's not going to mix up the hammer with a hatchet. With Optimus's steady, dependable pace and high accuracy object recognition, it makes it uniquely valuable, even if it's not the fastest bot on the block these days. Besides, Optimus handles a whopping 2.5 million calculations every second and operates within sub-millimeter precision. Tesla designed Optimus's fingers to perform fine motor tasks like aligning a screw. With this level of control, a necessity for any job that requires delicate movements and exacting alignment. Optimus also relies on a 2D camera for image processing. Drawing from Tesla's deep experience with autonomous driving, this 2D camera gives Optimus a strong sense of spatial awareness, allowing it to identify and manipulate small parts with ease. This feature comes in handy for intricate tasks like cooking or handling delicate components. To enhance object recognition and grip control, Tesla has incorporated deep learning models into Optimus's system. These machine learning capabilities help Optimus handle a wide range of items, from small screws to large panels with optimized grip and positioning. The AI-powered vision and object handling make Optimus an adaptable assistant in any setting. How superior is Optimus's new design? Robots are making waves, but let's be real. So far, it's basically marketing hype and competition between companies. Actual achievements in real-world applications are still pretty limited. That's why a lot of users remain hesitant, and understandably. Take a look at the humanoid robotics market today. You could count on some fingers the brands that have actually earned consumer trust. Now, Tesla's humanoid robot does bring some serious innovation to the table. For starters, component density. Tesla has managed to pack an impressive half a cubic centimeter per actuator, meaning Optimus is one of the most compact robots in the industry. And here's the kicker. They did this without sacrificing any major functionality. Then there's Optimus's space-saving parts. Each operates in a tiny volume, somewhere between 20 and 30 centimeters. Think about the size of a small food container or a soda can. This clever design means Optimus can do tasks without needing a bunch of space to move around, making it practical in real-life situations. Optimus's battery is only 15 cubic centimeters in size, but it keeps running for up to 8 hours. Practically unheard of for robots, and the power-to-size ratio Tesla got here is something that the industry hasn't seen before. It's small enough to fit in a small cube, but powerful enough to keep working continuously for hours. For nearly 10 years, Boston Dynamics' Atlas robot's been a media sensation, showcasing impressive feats like walking and performing complex movements. However, as the saying goes, every great thing eventually comes to an end. Boston Dynamics officially retired the Atlas HD after 11 years of stunts. The main reason? Its hydraulic system is now outdated by modern standards. In its place, Boston Dynamics introduced the new Atlas, an all-electric successor, still named Atlas, yet designed with more practical tasks in mind. But while one era ends, another begins, and now it's the age of Tesla Bot that's undergone upgrades. The custom actuators in its limbs have been finely tuned to maximize compactness without sacrificing power, allowing Optimus to maintain a sleek design while providing impressive torque and movement capabilities. Currently, Optimus is capable of grasping and manipulating delicate objects, even tackling intricate tasks that demand high dexterity, like threading a needle or playing piano. The modular design of Optimus Robot is crafted with flexibility, enabling it to adapt to various roles in different environments, showing Optimus can easily shift between work settings like factory floors to household tasks to bustling commercial spaces, making it a go-to solution for a range of practical applications. We've done an in-depth analysis on how the hands of Tesla Optimus could do up to 1,000 different tasks in the above episode of Tesla Car World. Check it out. We're sure you're going to be amazed by what this robot can do. Alright, back to Optimus's design. It has a surprisingly lightweight build at just about 160 pounds, which is relatively modest for a machine of its abilities and allows for easier mobility without heavy equipment. Compared to earlier models, the current version of Optimus is also significantly more compact, having reduced its operational size by 30% with 125 pounds. This leaner, more streamlined design enables it to perform well even in limited spaces, something other prototypes struggle with. How does Optimus enhance its self-learning capabilities? Following the recent robot showcase, the excitement surrounding Tesla's Optimus went beyond expectations. While many attendees, especially those outside the exec circles, were thrilled to see Optimus up close without glass, Elon, at the October 10th event, shared his enthusiasm for the development of the robot, but skeptics in the audience had some reservations. Some attendees speculated that these robots might have been remotely controlled with human intervention guiding every move. They pointed out that Optimus's responses could be influenced by backstage support and suggested it was only using AI for simple functions like walking, waving, or basic interactions, not fully autonomous like Elon had claimed. Yet despite this, many were still genuinely impressed, acknowledging Tesla's progress, understanding that this is just the beginning of Optimus's journey towards autonomy. In fact, the consensus among many tech enthusiasts was that Tesla had made remarkable strides, and even if there was a little human assistance done behind the scenes, they were confident Tesla was on the right track. For now, Elon has stayed silent amidst the chatter, leaving rumors and skepticism unaddressed. Instead, he's clearly focused on pushing Optimus's development forward. But the real question is how Optimus would react in your home. Imagine how it might digest all the input and respond when it's out in the wild, right there in your living room. That's the next step we're all waiting for. From the beginning, processing data from 12 cameras, allowing it to sense and react precisely to its surroundings. With LiDAR sensors and HD cams, it can recognize objects with a 95% accuracy, giving it a sharp eye on the world around it. Tesla's confident Optimus can minimize errors in the workplace to less than 1% thanks to AI and continuously learning and improving over time. Elon proudly claimed the success rate back when Gen 2 was first unveiled, and he's still clearly thrilled with these results. Next, Optimus's ability to learn on its own using simulated environments. By training in virtual settings, Optimus builds up skills and adapts before even stepping into the real world. This helps it become more independent and speeds up its learning curve. With this rapid responsibility, Optimus could adjust its movements and actions on the fly, not needing human intervention. For instance, when it's assembling battery packs on the production line or folding laundry or making coffee, Optimus automatically refines its movements based on each previous experience, kind of like how us humans learn and just get better at tasks through practice. Now, it might be an overstatement to say that Optimus is totally autonomous and needs zero human help. But the reality is that Optimus only needs a minimal amount of human input to set up a task. From there, it's pretty much running the show. It's estimated that Optimus cuts down on human intervention by a solid 99%. In addition, Optimus is powered by a neural network processor delivering a massive 144 TOPS, that's trillion operations per second. And that gives it the ability to recognize objects and make real-time decisions at an advanced level. On top of that, Optimus's AI models are updated every 2 days based on all the new data it gathers, allowing it to learn at a steady clip. Let's think about this. While you have to pay $20 a month to get faster responses and the latest updates from the ChatGPT app, if you don't want to be stuck from info that's way back, Tesla Optimus doesn't play by those rules. You're getting a humanoid robot that has cutting-edge capabilities, and Elon made sure that Optimus has a fully integrated self-updating software straight from the factory. In other words, it's a self-maintaining system that's always learning, without the need for human intervention. And check this out. We already see Tesla's EVs automatically handling updates on their own. Tesla's proven their reliability with this technology. Who has time to manage a robot like a full-time pet, gotta set up reminders of maintenance schedules, or worrying about when it's due for a system update? That's the beauty of Optimus. It's designed to take care of itself. It's there to make life easier, not pile on more tasks. So you're getting a top-notch assistant that instead of becoming another responsibility, actually stays ahead of its own game. How will Tesla maintain competitive advantages in the future? Elon recently dropped a tantalizing teaser on X, saying the new Optimus design expected by the end of the year is something truly special. Now, people love to call Elon the king of promises thanks to his ambitious goals in everything from EVs to AI. So naturally, when he says Optimus is going to be the best robot in the world, some folks raise an eyebrow. But here's the kicker. Tesla's genuinely pulling ahead in humanoid robotics, and that's no small feat. Optimus aims to do more than just one job. With an eye on the growing labor shortage, Tesla's designing it to replace some manual labor, not just industrial settings, but homes too. Elon has hinted that he envisions Optimus tackling chores and dull repetitive tasks, essentially stuff we don't feel like doing. As noted by NVIDIA's CEO Jensen Huang, he argues that since our world is already built for human use, humanoid robots are going to fit right in, also contending that these robots won't take jobs away. They'll just actually create new ones by boosting productivity, suggesting that as businesses become more efficient and profitable thanks to Optimus, they'll expand and hire more workers and create more opportunities. With all this potential, Tesla expects to ramp up production of Optimus to around 50,000 units annually next year, thanks to its powerful Gigafactory network. While it's still on the QT as to which facilities will be making the next Optimus models, inside sources point to Tesla's main hub in Texas. Elon shared a bit about the production process too, believing that Optimus will hit peak affordability when Tesla achieves scale production, eventually bringing costs down to $10,000 a unit. Tesla's plan is to release a limited run of Optimus units in 2025 for internal use, followed by broader availability year after next. Later this year, Tesla will start a leasing program after releasing the first batch of 1,000 units, with sales to the general public anticipated year after next. Elon envisions Optimus as a potential household companion priced at around $20,000. a blend of R2-D2 and 3PO, but with a broader skill set. Elon predicts people will grow quite attached to their robots, seeing them as almost part of a family. Think Star Wars, where everybody loves R2-D2. Even though R2-D2 can't even talk, he's still pretty charming. In addition to individual households, Tesla intends to roll out thousands of Optimus within its factories. However, Elon's ultimate claim is for these bots to serve millions of homes with tasks like cooking, lawn care, child education, and household chores. Now, Tesla has a clear production advantage. Thanks to its modern production lines, Tesla can manufacture Optimus 10 times faster than smaller robotics companies. Although Tesla's only showcased about 50 Optimus prototypes, it's believed they've made hundreds more behind the scenes. By leveraging technology developed for electric cars, Tesla expedited Optimus's development, allowing them to focus on scaling up to thousands of units next year. The technology crossover from Tesla's self-driving cars is pivotal. Key technologies like battery systems, motors, power electronics, and AI from Tesla's FSD vehicles are integral to Optimus. These sophisticated technologies provide Optimus with capabilities that surpass typical robots made by smaller startups. And across time, Tesla's vertical integration is expected to cut production costs for Optimus by up to 30% annually, making it more affordable as time goes on. In terms of its potential to assist with elderly and disability care, Tesla thinks Optimus could enhance caregiving by up to 40%, impacting healthcare support in a big way. Another big selling point is Tesla's software. Optimus will benefit from monthly OTA updates, keeping its AI and ops continuously optimized. Think of it like your phone or Tesla car constantly updating itself to get smarter and better. These over-the-air updates mean the robot gets more capable over time without you having to do anything. So if you're wondering why Optimus is such a big deal, it's because Tesla's bringing together a perfect storm of technology: production, capacity, and affordability. This robot is set to be more than just a helper. It's a new kind of companion that could make life easier for millions. With Tesla's Optimus poised to become a household robot, what tasks would you want it to personally handle in your daily life? Would it be stuff around the house, elderly care, or maybe something unexpected? We'd be happy if you left comments about this and hope you experience the utmost relaxation after watching this episode. If you do, hit that like button and join the Tesla Car World community by subscribing to our channel. Hit the notification bell icon to stay tuned for any fantastic videos coming your way. Your feedback and time are so much appreciated.
Another cool thing about Optimus is that just in the US alone, there are 2 million amputees. I was just talking to the Neuralink team, and by combining a Neuralink implant and a robotic arm or leg for someone that has had their arm or leg, or all arms and legs amputated, we believe we can give you basically a cyborg body that is incredibly capable.
Elon Musk announces a future where technology surpasses the limits of physics. A groundbreaking solution that combines Neuralink implants with advanced robotic limbs, where a prosthetic arm or leg is not just a replacement part, but a powerful cyber body controlled directly by thought. This not only restores mobility, but also independence and confidence. Get ready to witness a quantum leap in human capabilities as sci-fi becomes reality in today's episode of Tesla Car World. How are Optimus parts implanted into the human body? Elon is exploring how to regrow lost limbs and organs. They're using AI to better understand how our DNA works, which helps them figure out the exact spot where the limb originally grew without damaging any surrounding tissue. Once they got that, they can regenerate the limb in a lab. Yes, it's like growing it in a petri dish, then reattaching it to the body. The brain, being the amazing thing it is, starts remapping the nerve fibers to work with this new limb, and to make things even faster, a little electrical stimulation helps speed up the brain's learning process. It's like giving your brain a nudge to figure things out quicker. Next up, what you can do when we have all these fancy new Optimus limbs in our future, you'll be able to get some low-hanging fruit initially. It can raise, lower, or rotate your arm or leg. Some examples include saying hello by a wave, or pointing to different objects, or taking a break to grab a cup of coffee. With these fundamental movements, you can perform your daily routine of picking up things off the floor or getting ready for work that includes opening doors and never again asking for someone to help you open up that pickle jar. But wait, it gets better, and with more practice, you'll be able to handle complex scenarios, write and type again, cook your favorite meal. even play an instrument from scratch. It can all be done with ease using both new limbs. So, with the right engineering, you can work some robotics into your limbs and still have a measure of that control, so using them will feel natural enough to perform more complex tasks without feeling buried in metal. Optimus's flexible hand structures is a testament to this advanced technology. The robotic hand is designed with 22 degrees of freedom, allowing it to mimic human hand movements with unprecedented realism. This is achieved through a cable-driven system that uses just 6 actuators to control the whole hand, reducing complexity while maintaining fluid motion. The fingers can flex and extend almost as naturally as real human ones, thanks to innovative cable routing and torsion springs that stabilize the joints. This level of integration not only improves functionality but also boosts the user's confidence and independence in daily activities. Of course, we all do drinking, eating, and getting dressed, and you'll be able to do it all. The visual controls built into the system will make sure that you can use utensils, open doors, and manage your clothing easily. No more fumbling with buttons or struggling with zippers. And here's where it gets even cooler. Over time, the system actually learns how you move and what your preferences are. It's adapting to make things more comfortable and tailored to how you like to do things. It's like your new limb knows you better than your own hand ever did. And for those needing a little extra help getting back into the swing of things, the technology can be used in rehab facilities. You'll get guided exercises and feedback to help regain motor skills and promote recovery. It's like having a personal trainer for your new arm or leg. And in the future, these systems might even come with sensory feedback. Imagine being able to actually feel stuff, like touch or apply pressure, even temperature, through your robotic limb. That's a whole new level of integration, bringing back even more of that natural sense of independence. And the more you use it, the smarter it gets. The Optimus fingertips are equipped with sensors that detect pressure and touch, enabling the user to feel the objects they're handling. This tactile feedback can enhance the user's experience, making interactions with a robotic limb feel more natural. For example, picking up a delicate object like an egg without crushing it becomes possible with precise control and feedback. So, what's the exact principle behind how a simple chip like Neuralink can control prosthetic limbs like Optimus? Neuralink allows you to control a robotic arm using just your thoughts through a small implant with electrodes placed in the brain's motor regions, which detect electrical signals when you think about moving. These signals are picked up by the Neuralink device and processed into a chip that acts as a translator, converting your brain's activity into commands that the robot limb understands. The signals are then sent wirelessly to the robot limb, which is equipped with actuators and sensors that mimic human muscle movements. This allows the robotic arm or leg to move in sync with your thoughts, whether you're lifting a cup, waving, or giving a thumbs up. Let's take a look at the cases of Nolan Arbaugh and Alex. These are 2 real-life examples, which will help us understand how Neuralink can be used to control Optimus limbs. Nolan Arbaugh got his implant on January 29th this year, and a month later he was already demonstrating his ability to control a computer cursor with, get this, his thoughts. This case shows just how quickly Neuralink can start reading brain signals and translating them into precise commands to control external devices. The implanted electrodes in Nolan's brain were able to capture neural activity related to movement and attention. His brain sends signals as if they were using a mouse or joystick, and then Neuralink interpreted those signals and transmitted them to the computer, allowing him to control the cursor and interact with online games. If Neuralink can process brain signals to control something as delicate as a computer cursor, it can certainly handle more complex tasks, like controlling a robotic arm. A cursor requires fine motor control and precision, a lot like the small movements that a robotic limb would need to perform everyday tasks like holding a cup or typing things out. Now, for the case with Alex, the results, they were even faster. Within just 5 minutes of getting his Neuralink implant, Alex showed improvement using CAD software and doing some video games, demonstrating how effectively and quickly Neuralink can interpret neural signals and apply them to complex real-time activities that require detailed motor control. CAD software in particular is highly demanding because it requires precise hand movements to manipulate objects and make 3D designs. Similarly, gaming often requires quick reflexes and coordination between the different controls. When Neuralink can improve performance in a complex task like CAD design within minutes, controlling a robotic limb like Optimus could become second nature. The system converts brain signals into specific movements, just as Alex's brain guided the CAD software or video games. This technology can be applied to robotic limbs, allowing users to control them quickly and efficiently as if they were their natural limbs. Both cases demonstrate that Neuralink provides precise real-time control over digital activities. The same principle applies to robotic limbs. Movements would be quick, accurate, and responsive thanks to the way Neuralink translates neural data into mechanical actions. So, how much does an implant cost?
$6 million man in real life. But don't want to cost $6 million. $60,000 man. Doesn't sound impressive, but it'll actually...
Musk estimates the cost to be around $60,000, but the final price for implementing an Optimus arm or leg for patients has not been specifically disclosed yet. In reality, these costs may include not only the price of the device itself, but also expenses for surgery, post-op care, and necessary rehab. We know that the cost of implanting a Neuralink chip is estimated to be around $10,500 for the exams, parts, and labor, but when factoring in insurance and other costs, that price could rise to about 50 Gs. Overall, the estimated total for the project is to be no more than $100K. In exchange for what many people call a wallet-busting price, it's important to remember that this is a proven technology with high feasibility. The results have been clearly demonstrated not just through extensive testing, but also through approval by reputable authorities and having been tested directly on people. The path to Neuralink's regulatory approval involves continuous monitoring and adherence to safety guidelines set by orgs like the FDA. This collab includes regular updates and evaluations to ensure the tech is safe for human use. The iterative testing and modifications of the implant based on participant feedback and outcomes demonstrate a proactive approach to enhancing safety and reliability. In the first human implantation, Neuralink's N1 implant successfully recorded neural signals immediately after the surgery. The implant utilizes 1,024 electrodes distributed across 64 flexible threads to detect neural activity. Approximately 85% of the electrodes implanted in the first participant were successfully retrieved, indicating a high level of reliability in the device's design. The implantation surgeries were performed by the Barrow Neurological Institute, and participants were discharged the following day with a smooth recovery process. According to our updated information, the implantation process has undergone different changes and improvements based on lessons learned from the first surgery, which have been applied to the second. The Neuralink chip implanted in Alex, the second patient, demonstrates a notable advancement over the version used in Nolan Arbaugh, the first patient. For Nolan, the N1 chip had 64 threads, each containing 16 electrodes, totaling 1,024 electrodes implanted in the brain. For Alex's case, the research team made some adjustments. The number of threads was doubled to 128, and the number of electrodes per thread got reduced to 8. Despite the decrease in electrodes per thread, the new chip still has the total 1,024 electrodes. And upping the number of threads allows the chip to access more areas of the brain and gives greater stability in recording neural signals. Doubling the number of threads to 128 effectively doubles the bandwidth and improves signal accuracy. This means that the chip implanted into Alex can capture neural signals with higher detail and stability than Nolan's, opening up greater potential for control with the brain. Less than 3 weeks after surgery, Neuralink reported that 400 of the 1,024 electrodes in Alex's brain had begun functioning, showing positive signals earlier than expected. After getting the Neuralink chip, Alex was able to both aim and move in the game at the same time, describing this experience as mind-blowing and being thrilled to be able to move and look in all directions just by thinking. These results highlight the tremendous potential of this technology to improve the quality of life for individuals with disabilities, such as survivors of car accidents or veterans. From an economic perspective, the potential of this technology is quite significant. If Neuralink can develop brain-controlled prosthetics, the market for these products could grow into a multi-billion-dollar industry. The demand for assistive devices for people with disabilities and those in need of rehab is increasing, and advanced technologies like this can meet these needs more effectively. Furthermore, with the growing awareness of mental health and issues related to trauma, technological solutions like Neuralink could become an essential part of treatment for many patients. What are Neuralink's future implant plans? If all goes well, there will be hundreds of people with Neuralink within a few years, maybe tens of thousands within 5 years, millions within 10 years, Elon claimed. Neuralink isn't just stopping at the telepathy chip. It's gearing up to roll out its next game changer, the blindside chip, which has already earned the coveted breakthrough device designation from the FDA. Blindsight is approved for a voluntary program, and their next patient, a blind individual who's going to get this visionary tech. Elon's made big plans. He's aiming for 8 surgeries by the end of this year, bringing Neuralink's count to 10. But here's the kicker. By 2026, they could have over 1,000 people walking around with these brain chips. So, what's the blindsight chip all about? Well, it uses electrodes to stimulate nerve cells in the retina, mimicking light cells to help the brain see actual images. Initially, the resolution might be a bit pixelated, but here's where it gets crazy. Elon believes it could eventually surpass our own human vision. Plus, Neuralink plans to integrate external cameras to beam enhanced images straight to the brain, making this tech even more futuristic. And of course, being Elon Musk, there's the next stage, and he envisions a future where we could see ultraviolet, infrared, or some kind of radar-like vision through Neuralink. Yeah, straight out of sci-fi movies. While this opens up possibilities for communicating with AIs in ways we never even dreamed of, next-gen superpowers, anyone? Combining Neuralink's brain-computer interface, or BCI for short, technology with Optimus's robotic limbs, the two put on a display that could change life as we know it for amputees and anyone who suffers from paralysis. It allows a person to direct motorized prosthetics using just their thoughts rather than relying on injured nerves and muscles, leading people with amputations closer to everyday tasks like getting dressed or cooking. This could also be used for survivors of accidents and our veterans, giving people back otherwise lost limb function or slowing the decline in motor skills that occur in diseases like ALS. In dangerous fields, it could also aid workers by tasking robotic limbs to perform hazardous activities alongside them and work as a tool for recovering from an injury. This integration of BCI with robotics presents new opportunities for physical augmentation and significantly improves the quality of life. How does Neuralink change the patient's worldview? The first Neuralink patient, Nolan Arbaugh, underwent an implant procedure 7 months ago. He can now learn additional languages like Japanese and French, and in the near future, he aspires to go back to college to either finish his degree or pursue new research in the field of neuroscience. 8 years ago, a diving accident robbed Nolan Arbaugh of his brain and body functions, but he's regaining them with the help of a chip implanted in his skull 7 months ago. Until now, Nolan's recovery was filled with many interesting and surprising twists and turns with how well the chip worked, and from then on, day in and day out, Nolan has worked alongside Neuralink to calibrate Eve. Not just for him, but it also so that it benefits future patients. He recently shared what he does on a daily basis with Eve and the Neuralink team in his tweet. Through it, he describes in great detail his progress and recovery process with the help of Neuralink. He flexes his fingers, focusing on clicking left, right, and center with different parts of the body to type while attending a creative writing workshop. He pictures himself holding a pen and writes characters that are converted into key presses, demonstrating the resilience of his brain chip. He tackles a pretty impressive workload every day, dedicating around 3 hours each day to learning French and Japanese, and Nolan has also chosen to relearn math from the ground up, hopefully returning to school. Each day, he spends about an hour reading, and he has recently started writing creatively again, reflecting his determination and zest for knowledge. Nolan's aspirations extend beyond just academics. He aims to earn a college degree or explore new frontiers in neuroscience. His ambitions also include publishing his creative works, starting a charity, and even building a home for his parents. It's evident that Neuralink's chip has profoundly transformed Nolan's life, enabling him to vision a future filled with possibilities. Alex, the participant directly after Nolan, was also able to break a previously held world record on day 1 of using it and controlling any cursor through brain-computer interface with a Neuralink device. Alex kept playing after the completion of first research session via Counter-Strike, a first-person shooter game. By the second day of allowed use, Alex was using Fusion 360 for the first time and designed a custom mount and charging station for his Neuralink that he then printed into Final with part of his Link setup. Thanks to the Link, Alex can enhance his productivity by mapping intended movements in different actions with specific mouse buttons, increasing further the number of controls and being able to instantaneously change between several modes like zoom, scroll or pan, click and drag, or similar operating behavior needed for CAD software videos. When he has extra time, Alex employs CAD software to further fabricate ideas of his design skills. Eventually, he wants the Link to empower thousands of people all over the world and help them create in their fields, and once again is amazing its many members. But until then, they were thrilled at getting started on more work with him. In addition, Alex plays first-person shooter games, which often uses multiple inputs in the form of 2 joysticks. With the Link, Alex can now move and aim at the same time with his shooter games for a new level of differing gameplay. For him, the Link's a big step on the path toward regaining freedom and independence, Alex said. Do you think technologies like Neuralink's brain chips will eventually become common enhancements for everyone, or should they primarily remain for medical use? We hope you'll experience the utmost relaxation after watching this video. If you did, hit that like button and join the Tesla Car World community by subscribing to our channel and hit the notification bell icon to stay tuned for any fantastic vids coming your way. Your feedback and time are highly appreciated. Honda's ASIMO played soccer with former President Barack Obama in 2014. Tesla engineers say Optimus' hand has 22 degrees of freedom, but it's still inferior to a robotic hand designed by a Japanese engineer that has 27 degrees. In early October, Tesla showed off Optimus, its latest version of a humanoid robot. Aside from the positive moves, there's still a small portion of robotic experts who are largely unimpressed with Optimus's clumsy efforts. But look, besides the things that people are dissecting and comparing, Optimus still confidently claims to be the most advanced humanoid robot with a multitasking hand that can handle more than 1,000 tasks and communicate verbally with the fastest response speed of 1 second. More importantly, Optimus is a robot with human emotions. So, how is Optimus's new gen superior? How Tesla showed bias in the design of the Optimus New Gen. 1. Transitioning to advanced materials. Tesla's Optimus robot has slimmed down by 10 kilos since Elon first introduced it at Tesla's AI Day back in 2021. Then it was called Baby Optimus, weighing in at around 154 pounds. Now, thanks to the clever use of lightweight aluminum and carbon fiber, Optimus has cut some pounds, bringing it down to a leaner 125 pounds after 6 rounds of updates and cutting-edge manufacturing tweaks. This weight loss isn't just for show, it's actually improving the bot's performance. Optimus with its 2.3 kilowatt-hour battery is now more energy efficient. Where it could once travel 14 miles on a full charge, it can now go closer to 16 miles. Plus, Optimus has upped its endurance for working from 8 hours to an impressive 13.11 hours of continuous operation. In Tesla's latest video update, we can see Optimus strolling steadily around Tesla's offices. No stopping or any difficulty in moving. Clearly, Tesla's development team has been working hard to boost Optimus's walking speed and precision. By late September last year, Optimus learned a few more tricks, folding laundries, sorting objects, even doing some basic yoga poses. And since it's now lighter, Optimus's components face less wear and tear, promising a longer operational life and fewer breakdowns over time. Just a week after the We Robot event, Tesla shared a 90-second video update through its official Optimus account, showcasing its latest skills, from walking around to detecting and avoiding obstacles using its neural network. Elon also hinted that Optimus units will soon be able to share a common map of their surroundings. Imagine a fleet of Optimus robots working together on a factory floor, all learning from each other's experiences and getting smarter as a team. That's the kind of future that Tesla envisions, where Optimus robots work side by side with humans in factories and beyond. Unlike most humanoid robots out there today, like Neo's 1X, Optimus won't be designed to follow typical industrial charging standards that aim to balance operating time with charging time. Tesla's taken a different approach here. Rather than sticking with the conventional guidelines for robots that often focus on simply managing power cycles to make sure they're not stuck recharging every other hour, Optimus is all about maximizing its time on the job. Normally, robots are on a predictable schedule. You get so many hours of work, then so many hours of charging, like clockwork or like a factory shift, but for machines. While this setup's great for many factories, it's not necessarily ideal for robots meant to operate alongside humans day in and day out. Tesla, on the other hand, is pushing Optimus towards a whole new level of independence. Now, Optimus can locate, navigate to, and connect itself to a wall charger all on its own. Once fully charged, it detaches and gets right back to work. Tesla's efforts to make Optimus a real helping hand are clearly paying off. We can see that Optimus can carry heavy loads and climb upstairs, or even serving food and drinks to the Tesla team, a friendly touch that shows just how far Optimus has come. Now compare that to the 1X Neo Beta robot. This is a perfect example of how weight can impact robot performance. Neo Beta tips the scales at 192 pounds, 1.5 times more than Optimus. Because of its size, Neo Beta needs more power and can only go 6 hours, covering a maximum of just 8.7 miles, less than half of Optimus's range. Studies into exoskeletons and soft robotics emphasize lighter materials reduce mechanical stress, extend lifespan, and enhance performance, something that Optimus clearly benefits from. 2. Design optimization. Until now, Tesla has made 3 major design revisions to Optimus, along with 4 key updates to its hands in just the last 2 years. Flashback to 2019 when Optimus was a clunky concept that had to be wheeled off the stage by hand. And today, Tesla's engineers have Optimus doing things that people would actually expect from a human-like robot. Here's the thing though, Optimus isn't just based on a generic human, but rather a specific kind of worker with specific skills. In other words, the robot's design reflects the exact type of task it was built for, as well as the type of person it's meant to emulate. While Tesla officially unveiled Optimus in 2021 with a little more than a concept video, by mid-2023, Tesla's humanoid prototypes were functioning impressively, and by the end of the year, Tesla revealed the Gen 2 Optimus, which not only moves smoother than before, but also featured hands with even more joints.
And then with Optimus, we showed a massive improvement in Optimus's dexterity and movement on October 10th. And our next gen hand and forearm, which has 22 degrees of freedom, which is double the prior. It's extremely human-like.
One extremely shocking thing Elon wants to tell you is that Optimus Gen 3 introduces a completely new advanced hand design that incorporates artificial tendons, improving precision and flexibility. Along with its embedded integrated actuators, these hands boast 22 degrees of freedom and can manage complex tasks with near-human skill. Tesla showcased these new nimble hands in recent videos where Optimus could handle delicate tasks like pouring drinks, handling eggs, and working with battery trays in Tesla's factories. But the real game changer? Optimus's upgraded neural network, which helps it perform various tasks autonomously in different working environments. This end-to-end neural network lets Optimus tackle complex tasks like sorting 4680 cells or fixing fallen cells on a conveyor belt, all without human intervention. It processes everything from 2D camera video and onboard sensors directly to joint control commands, running entirely on Optimus's embedded FSD and powered by its onboard battery. While Optimus isn't quite perfect and still works a little slower than expected, Tesla engineers are steadily improving its success rate, reducing errors, and even training it to recover from mistakes. Tesla's already deployed several units in some of its factories, testing them in real workstation conditions daily, making improvements based on performance. This number is expected to reach thousands of units by next year. So Elon is optimistic about the potential of Optimus, calling it the biggest product ever, envisioning that it'll handle all kinds of household chores, and even anticipates Optimus selling from $20 to $30K per unit at the nearest date.
It'll basically do anything you want. So it can be a teacher, babysit your kids, it can walk your dog, mow your lawn, get the groceries, just be your friend, serve drinks, whatever you can think of.
Optimus has been publicly demoed many times before, but at the recent We Robot event, people got a chance to interact with these sleek black and white robots directly. Attendees saw Optimus pour drinks, applaud, and even play rock, paper, scissors. Impressive feats for a machine. Nancy Tengler, CEO of Laffer Tengler Investments, was wowed, saying Optimus stole the show. Wedbush analyst Dan Ives called it a glimpse into the future, writing that these humanoid-like robots seem closer to reality than most had expected. Unlike conventional industrial robots, which are generally unsafe for close human interaction and can't operate in pedestrian spaces, Optimus has been designed with human coexistence in mind.
It also has much better tactile sensing. It's really, I feel confident saying that we have the most advanced humanoid robot by a long shot. And we're moreover the only company that really has all of the ingredients necessary to scale humanoid robots.
Tesla Optimus is more than just efficiently completing tasks like cleaning or serving food. It also involves emotional labor, a cheerful greeting, a lighthearted chit-chat, and a genuine smile to make folks feel more comfortable. For Tesla engineers, it's taken more than advancements in AI to make Optimus human-friendly. Building a machine with a head that can walk on 2 legs needs patience, resilience, and even an understanding of human psychology. 3. Performance improvement. Talking about speed, Optimus has leveled up in a big way that's faster and smarter. The first version of Optimus walked at about half a meter a second. Now it's cruising at 0.6 meters a second, a 30% increase. That's not a little tweak either, it's a major upgrade. So how did they manage to make this robot go faster without tripping over itself? As we said, Optimus cut 22 pounds, and to be honest, it's more than I've lost in the last couple years. The lighter frame means it can move more quickly and with more agility. Less weight, more speed. It's simple math. Besides, Tesla engineers worked hard to improve Optimus's balance, which doesn't move just faster, but moves more confidently, kind of like a tightrope walker. No more wobbling or awkward stumbling. The evidence is that Optimus now has better footwork. If you're still having trouble believing in Optimus's amazing legs, then you definitely need to check out our previous episodes where we break down its incredible ability to move and maintain balance. Trust me, you'll be amazed at how this robot can walk, run, and keep steady on its feet like a pro, and only getting better. It's like the robot equivalent of putting on a great pair of sneakers before running a race. In addition, the brain behind Optimus and its movement software got a nice boost. It can now make quicker decisions and react faster, no more sluggish movements or delayed reactions. Now, Optimus is walking around Tesla's office like it owns the place. No falls, no awkward stumbles, but the work isn't over. The next goal? Making Optimus faster and capable of handling trickier terrain without losing that human-like quality. Tesla's also working on making sure all the Optimus bots in their fleets operate in sync despite small variations between each one. It's like making your team of robots all work together like a well-oiled machine. Why should you choose Tesla Optimus over Spot by Boston Dynamics or ASIMO Robot? At the 2024 stockholder meeting, Elon dropped some exciting news for Optimus fans. Not only did he confirm that this humanoid robot could be customized to suit different user needs, but also revealed some pretty cool upgrades. For starters, the new Optimus model will have 22 degrees of freedom in their hands. Elon hinted at this before, but he brought it up again to highlight just how big a deal it is. With 22 degrees of freedom, Optimus's hands are getting closer to the dexterity of human hands that have 27 degrees of freedom and can do about 100 different tasks. Elon claims that with this boost, Optimus could tackle at least 70 of those, plenty for most practical uses. To give you a sense of how capable that is, Elon even joked that Optimus can play piano. Even more, he added that threading a needle is within its reach, a pretty challenging task even for us humans. Experts are talking too. This level of hand dexterity is something other robot companies are still trying to figure out. 22 degrees of freedom in the hands isn't just a technical flex. It means Optimus can handle fine motor tasks that were previously out of reach for most other robots. It's a leap in robot hand technology that brings Optimus closer to doing jobs that require precision, like assembly work. It's a big step towards Elon's vision of a humanoid robot that's adaptable to countless tasks, thanks largely to these groundbreaking hands. So, while we're waiting to see Optimus in action, Tesla's making it clear that they're serious about delivering a robot that doesn't just walk the walk, but actually does the work. However, Tesla may be one of the biggest players in the robot race, but it's not alone. Many companies are rushing to make robots that can tackle a whole range of tasks. With the market getting hotter, we'll likely see competition, keeping prices in check and making robots more accessible, like we've seen in the car industry, and that's where Optimus stands out. In terms of functionality, Optimus is all about endurance. Designed to carry out repetitive high-stamina tasks, it can lift up to 44 pounds and moves at a steady 5 miles an hour. Think of it as a tireless worker in the assembly line, performing tasks that otherwise might be done by people or other less adaptable machines. Meanwhile, robots like Honda's ASIMO are more about social interaction and assisting people directly. ASIMO is geared toward customer service, greeting visitors, answering questions, even lending a mechanical hand in hospitality settings. Optimus, though, has its eyes set on heavy-duty work, tasks that require both endurance and an extra layer of safety for the people working alongside it. One area where Optimus truly shines is price. Elon hinted that Optimus might be priced at $20,000. That's far more affordable than most of the competition. Take Spot, for example, that costs $74,000, a price that puts it out of reach for many small businesses. But by keeping Optimus at a reasonable price, Tesla's hoping it'll be accessible to a wider range of buyers, not just big companies, making Optimus a standout choice for small and mid-sized businesses looking for cost-effective automation. So, how will Elon further develop Optimus New Gen? Elon plans to have Optimus robots working in Tesla factories by the end of 2024, handling tasks alongside humans. This trial run aims to get the robots up and running in controlled industrial environments so Tesla can iron out the details before Optimus reaches the public. By late next year, Elon plans to open up orders for companies outside Tesla. Beyond 2026, Optimus could hit mass production with the goal of making 1,000 units next year and scaling up. Elon's vision? A world where robots like Optimus could revolutionize industries by handling anything from manufacturing and warehouse work to one day tasks in our homes like cleaning and cooking. One of the standout points in Elon's vision is price. While high-tech robots typically go anywhere from $70,000 to $300,000, Elon wants Optimus between $20,000 and $30,000, and if Tesla can pull this off, Optimus would be more affordable than most new robots, potentially allowing adoption in a way that's not yet been possible. Elon's gone on record saying he expects demand for robots to skyrocket over the next 20 years, predicting a market of up to 1 billion robots a year, and he aims for Tesla to get at least 10% of that market that could catapult Tesla's value to $25 trillion. The exact reason is by 2026, Elon envisions a fully customizable Optimus that could adapt to a wide range of tasks. In factories, Optimus could handle repetitive or strenuous jobs, freeing up humans for work that requires a creative or human touch. At home, the robot helps with cooking, cleaning, maybe even providing basic education support. Elon imagines a future where everyone would have a personal robotic assistant, changing the way we live and work in ways that are hard to imagine today. Of course, creating an army of humanoid robots comes with complications. To make Optimus work well, Tesla would need data from robots operating in different environments. Maintenance and support would also be critical. These robots will need a team of techs to keep them in tip-top shape and ready to go. So yes, this is an operational challenge. Even academic labs aren't fully ready for this, but Elon's confident Tesla's got the team, the tech, and the drive to make it happen. While Elon paints an exciting picture, many people are still a bit skeptical. For one, humanoid robots have always been a tricky concept, with some folks feeling uneasy about the idea of robots walking around our homes and work. Pop culture hasn't helped much here. Images of robots turning on humans are pretty popular in movies. And an Optimus is priced affordably, not everyone's sure they want a humanoid robot just yet. But here's one thing Elon has shown. It's his determination to prove skeptics wrong. With a track record of making electric cars and reusable rockets, it's not entirely far-fetched that he might just get Optimus out into the world of mainstream too. In the end, Elon's plan for Optimus is bold, groundbreaking, and yes, a bit mind-boggling. For now, we'll just keep watching, one robot at a time. So, what do you think about having an Optimus at home in the future, with a human-like face customized to do your liking, able to handle all the tasks you want? We hope you enjoy this video. If you did, hit that like button and join the Tesla Car World community by subscribing to our channel. We value your feedback. Until then, stay safe and have fun.